You will need to memorize all the polyatomic ions listed in the slides, not just this slide, but all of the slides in this section. To help with memorization, we can group some of the polyatomic ions into families. All of the polyatomic ions on this slide are oxyanions. They have one nonmetal bonded to one or more oxygen atoms, and together they have an overall charge. The charge is the same for all oxyanions within a family. All the ones with chlorine are -1. All the ones with nitrogen are -1. All the ones with sulfur are -2, and all the ones with phosphorus are -3. The oxyanions all end in either ate or ite. The one ending in ite has one fewer oxygen than the one ending in ate. There is not one set number of oxygens for ate or ite. It will depend on the family. For example, chlorate and nitrate have 3 oxygens, but sulfate and phosphate have 4 oxygens. A few of the oxyanions also have prefixes. The per prefix is like super or hyper, meaning above or extra. Perchlorate has 1 more oxygen than chlorate. The hypo prefix is like hypothermia or hypodermic needle. It means below or less than. Hypochlorite has 1 fewer oxygen than chlorite. Notice it still has the ITE ending like chlorite. All of the oxyanions have corresponding oxyacids, which have some +1 hydrogen ions added to the oxyanion. They will always have as many +1 hydrogens as needed to make a neutral acid. So for example, the oxyanion sulfate has a -2 charge, so it needs 2 +1 hydrogens to make the neutral oxyacid sulfuric acid. These oxyacids have naming rules based on the ending of the polyatomic ion. If the polyatomic ion ends in ate, change the ending to ic acid. If the polyatomic ion ends in ite, change the ending to OUS, us acid. So nitrate becomes nitric acid, and nitrite becomes nitrous acid. This slide summarizes the naming rules for the oxyanions. All you need to do is memorize the ones ending in ate. The charge on the others in the family will be the same. The number of oxygens is something you can figure out based on the ending and/or prefixes. Please watch the video linked in the slides, which will help you memorize your polyatomic ions using the periodic table. It will help you with not only the ions listed on the previous 2 slides, but on many other oxyanions that have not been listed explicitly. Polyprotic acids have multiple H pluses that can be lost one at a time to make several different ions. The ions in polyprotic acids on this slide differ by 1 H plus at a time. The hydronium ion is basically water with an H plus added onto it. So the number of hydrogens increases from 2 to 3, and the charge increases from 0 to +1. The hydroxide ion is basically water with an H plus taken away from it. So the number of hydrogens decreases from 2 to 1, and the charge decreases from 0 to -1. Carbonic acid is the neutral acid based on carbonate. Remember, ate is related to ic acid. If carbonic acid were to lose only one of its 2 hydrogens, it would have the formula HCO3-1. Its historical name, and the one you are likely to see on the bottle in the stockroom, is bicarbonate. Another name you might see for this ion is hydrogen carbonate. Going from carbonic acid to bicarbonate, the number of hydrogens went down from 2 to 1, and the charge went down from 0 to -1. Losing a second hydrogen ion would yield the carbonate ion. Sulfuric acid is the neutral acid based on sulfate. If sulfuric acid were to lose only one of its 2 hydrogens, it would have the formula HSO4-1 and be called hydrogen sulfate. If it lost another hydrogen ion, it would yield the sulfate ion. Phosphoric acid is the neutral acid based on phosphate. If it were to lose one of its 3 hydrogens, it would have the formula H2PO4 minus 1, and it would be called dihydrogen phosphate, di meaning 2. If it were to lose a second hydrogen ion, it would have the formula HPO4 2 minus, and it would have the name hydrogen phosphate, similar to hydrogen carbonate or hydrogen sulfate, which each have only 1 hydrogen. If it were to lose one more hydrogen ion, it would yield the phosphate ion. Notice each time the H pluses change, the charge changes and the number of hydrogens changes. Here are some more polyatomic ions you need to know and their corresponding acids. The acetate ion is written in your book as CH3COO-. You might also see it written as C2H3O2-. Again, ate becomes ic acid for the neutral acid, so acetate becomes acetic acid with the addition of 1 H+. Chromate has 1 chromium, 4 oxygens, and a -2 charge. Dichromate has 2 chromiums, 7 oxygens, and a -2 charge. So dichromate is not just 2 chromates stuck together. It has 7 oxygens, not 8, and the charge is the same as for chromate. Notice both chromic acid and dichromic acid have 2 + 1 hydrogens, balancing out the -2 charge of the anion. Permanganate is MnO4 - 1. Permanganic acid has 1 + 1 hydrogen added to that. The last two on this slide will not follow the same acid naming rules because they are small ions with no oxygen. Cyanide is carbon and nitrogen bonded together with a -1 charge. Azide is 3 nitrogens with a -1 overall charge. Both ions get 1 + 1 hydrogen to make the neutral acid. The acid based on cyanide is hydrocyanic acid. The acid based on azide is hydrozoic acid. We will talk more about naming acids in our next chapter. The last two polyatomic ions are peroxide and ammonium. Peroxide is similar to the O2 molecule, but instead of being neutral, it has a -2 charge. Peroxide is different from the oxide ion, which has 1 oxygen and a -2 charge. Rather than naming the neutral molecule with hydrogens as an acid, H2O2 is called hydrogen peroxide. Ammonia is a molecule you will see frequently in this class. It is neutral and contains a nitrogen and 3 hydrogens. The ammonium ion has an H+ added onto ammonia, so it becomes NH4 + 1.